Hello and welcome everyone. My name is Árpád Jorzsits and it is my pleasure to open our next virtual event called DevFest 2021, organized by the two GDG groups in Hungary, GDG Budapest and GDG Cloud Budapest. We have a good selection of speakers coming from 5 companies covering different topics from infrastructure as a code to Vertex AI. I hope you will enjoy all the content we prepared for you. And before we start, I would like to say thank you to our sponsors like Deutsche Telekom IT Solutions, T-Systems International, and of course Google Cloud. Thank you for being here, and now let's get started.
Hello and welcome to my session of this year's GDG DevFest. My session entitled Protecting Against Data Exfiltration with VPC Service Control. My name is Nabil, Director of Training Google Cloud at Jellyfish and a GDG Cloud expert. So let's see what we have in order to understand this concept of VPC Service Control. Before we get to that topic, I'm going to talk a little bit about security and the Google Securities approach, and then talking about the security items when it comes to the network in GCP and protecting the VPC and configuring VPC for isolation from security perspective. And then we will see then the topic of VPC controls. Why do we need VPC service controls? What do we need them to? What are the things we need them for to resolve? So first thing first, Google's cloud platform approach to security. Security is always in GCP is a shared between the it's always shared between the customer and Google. So first of all, before you come to the cloud, when you are on premises, all the security layers is the responsibility of the customer, from the data center, from the physical data center to the hardware, the underlying infrastructure, to the network, to the storage encryption, operations, access management, authorization, authentication, access policies, the data itself and its content, the applications, the operating system, all of those are responsibility of the customer. Once you move to the cloud, it will become a shared responsibility between Google and the customer. So the lower level of the security stack is the responsibility of Google in the case where you are using infrastructure like service, like compute engine instances, VMs basically in the cloud. So in that case, the lower level layers of security stack is the responsibility of Google, and that is where are these hosted, the data center, the host where these VMs are going to be created, the storage and encryption, the audit logging, and then moving to authentication and network security and identity and web application security, deployment of application, access policies, the content of data and all that would be responsible of the customer. The more you move into services that are platform as a service, serverless services, fully managed services, the responsibility of the customer when it comes to security is a lot less. So Google will take over extra layers from the security stack, till the point when I'm using, when the customer is going to be using completely serverless, fully managed services or software as a service, where they will be responsible just for the governance of data. So they use a service, they bring their data, but they will have to be responsible for who do I need to give access to, who do I need to give read only, who do I need to give read write, and so on and so forth. But having said that, Google don't tell you that this is your responsibility. Just go on and deal with it. Google, they will give you the tools in order to have that control. They will give you the best practices to follow. to get the best security implementation in place. So you must control who have access to your data, and you've got the tools for that. Even any communication, any access to data that you're going to be doing, it's basically an API request for data, which is done via a REST service call. And that REST service call, it has to be authenticated, it has to be authorized, so it have to have some kind of permissions in order to be able to make that call, in order to access the service, and so on and so forth. So the tools that Google that give you in order to have that governance, in order to be able to give access to people, is what we call identity and access management, or in short, Cloud IAM. And the Cloud IAM, basically what it is three components: who can do what on which resource. And this is kind of the three items of a Cloud IAM and how to manage access in GCP. So the other thing that we need to understand about resources in GCP is how logically can we create resources in GCP? How are they implemented? And in GCP, we have what we call the resource hierarchy. So the resources are implemented in a logical way in a hierarchy of layers of resources by means of the GCP Resource Manager. So the resource hierarchy is basically it's like a pyramid. So on the top level, we will find an organization. With the organization, and the organization will find folders, and under folders we'll find projects, and inside the project, this is where we create in our resources. So objects hold data and application, and also help to organize it and secure it. So these layers of this architecture will help us to have some kind of organization, even in terms of security. At which level I need to give access to those resources, who would be responsible for each level of this hierarchy, and so on and so forth. So this is basically how it looks. At the top level, like we said, it's the organization level. Underneath it, we will start isolating our resources into things like legal entities, into teams, into projects, into environments. So I can always have that hierarchy, isolation of resources at that level, logical isolation. And then inside them, I can create my projects. And by the way, in this level here, let me just get my my laser pointer here. I can have up to 10 levels of these folders. So if I'm a big organization, I want to bring my org chart, for example, to be the same as my resource hierarchy in GCP. I can always do that, and I've got flexibility to have 10 layers of those folders if they have got teams or whatever that might be. And then I create the projects, and inside the project, this is where I create my resources. Without a project, I won't be able to create any resource. At the project level, this is where I enable APIs. This is where I get billed for. So I enable billing at this level. And then I've got members of roles. The members are kind of the identities, or what we call them in Cloud IAM principals, who I need to give permissions to. And the permissions they come in the form of what we call roles. Roles, each role will be a set of permissions that I can give to a member, and I apply it to any one of those levels of the resource hierarchy. The roles themselves, we got three types of roles. We've got primitive or basic, predefined, and custom. So the primitive or basic are basically very kind of broad permissions that they can apply to the project level. So they apply to all the resources in the project. So they could be very, very powerful, and at the same time they can be very dangerous. And this is why this is not the right kind of rules that apply in a production environment. This is probably suited for in a test environment rather. So the primitive roles or the basic roles got three types. I've got the viewer, somebody with read-only access to all the resources. I've got editor, somebody who have basically edit roles, access data. They can add data, he can remove data, he can configure services, add services, deploy code, and so on and so forth. The owner will have all the permissions of the editor and a viewer. Plus, they can give access to others. They can delegate access to resources to others as well. So they are the owners. They have completely full control of the project. There is a fourth role, which is a browser, somebody not even with read only, but I can see what is created in my hierarchy. Predefined roles, we said those primitive or basic roles are very, very dangerous because they give access to everything. Now, with the implementation of what we call the principle of the least privilege, what we want to do really from best practices perspective is to give just the right permissions to somebody to do their own job, and that's it. And for that reason, Google have created for each of the services that we have in GCP, compute engine, instances, cloud storage buckets, BigQuery, Bigtable, Cloud SQL, and the rest of the services, for each one of them, it created the predefined roles with each role with its own permissions. So you might find for BigQuery, I've got BigQuery admin, a BigQuery data owner, a BigQuery connection admin. So each role has got a set of permissions associated with it that could relate to a particular role in my company, where a team or a member can do their job, and only the task they are allowed to do, nothing else, nothing more. And this is good from a security perspective. So we are in control for who can do what in our project, but also from cost perspective, from billing perspective, I have tight control of what people can do and what can I not do. So predefined roles are really good, but sometimes they are too, even those they are too broad. So, for example, if I take the instance admin here, somebody can do anything on compute engine instances. So in that case, if my requirements say, okay, I'm not allowing anybody to delete any resources in my organization for VMs, anything from there, then that predefined role is not good for me. I need to be something more granular, and for that reason, we have what we call custom roles. I pretty much mentioned browser role earlier. But the custom roles, I can customize the predefined role. I can use a combination of multiple predefined roles and use only the permissions from one predefined role or multiple predefined roles to give just the right permissions for a particular identity member or group or whatever that might be to do just the task they should be doing. And this is what leads us to IAM policy. So an IAM policy is basically a binding. It's basically a binding of binds a list of members to a role. So if I have a role with a set of permissions, I bind it to the member. Who do I need? Who should have those permissions? So this is a policy, and then I apply it to the hierarchy at any one of those levels, either at the organization level, a folder level, or an object, or directly into a resource. And with that, in GCP, the policy, when I apply it to any one of those levels, I've got a policy inheritance from top to bottom, which means if I apply at a folder or an organization, it will trickle down to all the items underneath it. And this will give me the isolation. I can delegate access to, let's say, folder A is actually a team. So if I give somebody admin rights to that, they won't be able to access any resources in the other folders in the hierarchy, and they can give access to all the resources underneath it. So they will be, if they are an owner of the folder, they will be the owner of everything underneath that. And they will be able to delegate access to projects underneath that or the resources as well. So cloud AI policies give me those kind of ability to give access to resources. Now, what if I want to restrict something? I don't want to make it available for people, for example, to have, let's say I don't want anybody to be able to SSH to machines, or I don't want them to have public IPs on my VMs across the organization because this is this is a company policy, for example. This where organization policies comes into play. So they are a configuration of restriction. They are constraints that I can set at the organization level, and it will apply to all my organization. And this is some of the example of a constraint: disable VM serial port, disable service accounts, and there are many others as well. So I can apply at the organization level, and I can do some exceptions if I want to. So if I want to, for example, just my security team to be able to create service account, for example, I will have a project for them, and I will basically filter it out from the organization policy. I can have it as an exception not to apply that policy to be included for that project. And when it comes to network, when it comes to my VMs, my subnets, and I want to have some kind of control over who can access my VMs, who can access the disk on them, or data, or copy data from them, or any traffic basically going to my VMs. This is what I use VPC firewalls. So firewall rule is a firewall rule. Basically deny or allow access to VMs basically. And then how do I allow access to the Google API public IP addresses with only private IPs? If I want my virtual machines not to have public IPs, but still I want them to access the Google API public space, like the BigQueries, Bigtable, I want them to be able to access those. Then I've got what is called private Google access. So let's have a look at those two are from security perspective. So Google, they've got VPCs. VPC is the network abstraction, which is a software-defined abstraction of a network that is similar to what a network on premises, but it's completely different here because it's software defined. So one of the features of the VPC service control or the virtual private cloud or the network abstraction in GCP is that it's a global resource. So I can create one network that spans across the globe that will include all the regions of Google Cloud. So I might have a subnet that exists in the US and a subnet that exists in Australia, and without further doing any other configuration or routing or anything, two VMs across the globe, they can talk to each other over the private IP, which is so powerful when it comes to networking, because something like that, you do it on premises, it's going to be very, very expensive. There's a lot of configuration that needs to do. There's a lot of routing that need to take care of, and so on and so forth. So this is by default, you get that in GCP. And the only thing that you would be able to control the traffic between VMs in multiple regions to allow that traffic or not is firewall rules. So firewall rules are basically a way that will help us to control access to my VMs. So it is configured at the network level. And in there, I can apply it to all the instances or VMs in my network, or I can I can specify tags for my VMs in the network. I can specify tagging in order for a firewall rule to apply to only the VMs with a particular tag. So a tag will be on the firewall rule, it will be on the VM, and it will be matched together. Or instances with a specific service account as well. Firewalls are stateful, which means if I have two firewall rules applying to the same traffic, one going out and one coming in, and the one that is going out is allowed, and the one coming in is denied, is not allowed, then as soon as I have one traffic happening in one direction, at the very same time, we can't block the returning traffic. And this is what stateful is in this case. So the firewall rule basically is about direction, ingress or egress. You need to specify source or destination, the protocol and port that needs to be considered for the firewall rule, and then the action, allow or deny. And then we've got priority. Priority is about resolving those conflicting situations where you have the very same configuration for a firewall rule, and two firewall rules, they saying having the same direction, same source destination, same protocol and ports. But for the action, one is saying allow and one is saying deny. And this is where we will have to look at the priority. So the priority number, the lower is the number for the priority, the more the powerful is the firewall rule. So basically, the one with the lowest number is basically is with the highest priority, and that will override the one with the higher number. Private Google API access. So if I have a policy in my organization that says no VMs will be able to have public IPs, but I need to access the Google APIs and services. I need to reach them because they are on Google network. I need to access the public IPs of that. This is where private Google API access is good, because I'll be able to access those with VMs only with basic private IPs. And the API call is still resolved to a public IP, but the traffic is going through the private network. I'm using a private IP, reaching out to a public IP. The API call will reach out to that with the private IP. And it is configured at the subnet level. So when I enable it, basically all the VMs in that subnet, even though they are with private IP, they will be able to access the Google API's services with the private IP without no issue. So this is an example here with private Google API access example. One subnet with the private Google access enabled. One is disabled. So the one with the private Google access enabled, I will be able to reach out to Google Cloud Storage, for example, with the private IP. If that wasn't enabled, I won't be able to reach out. So if it was disabled, I would only be able to reach out to the Google Cloud Storage with the public IP, because in that case, the Google API access is not enabled. When it's enabled, make it very efficient. That because I'm using private network communication, which is more efficient than using the public. Now that's all good. I can control access to my VMs if I have applications running there. I'm storing my data in there. But what happens if I want to control who have access to my storage bucket, who have access to BigQuery? So if I have my data and I've got somebody with full control over the data, but I don't want them to copy data outside my project. Let's say I've got a contractor working for me. I give him full access to BigQuery or to cloud storage, for example, but I don't want them to copy my data outside the project. And this is what VPC service controls come into play. So VPC service controls, they are there to help you resolve any security risks without having a hit on performance. So it should work hand in hand with the cloud IAM, so I can still give the right IAM access to those resources, but I'm gonna need to be able to control that whoever got those permissions not be able to put any data at risk outside my my project. And this is what we call data exfiltration and compromise code. I don't want to copy anything that is relevant to my company outside that, or having public exposure of my private data. And this is where we need to put a perimeter, so a service perimeter around my project. And even if you have like full access to my data in, let's say, storage buckets, you won't be able. I want to have a mechanism in place for you not to be able to get out of this perimeter, and this is what the VPC service control will allow me to do. And you can extend communication from your cloud resources to an on-prem environment in the same way. So you will be able to allow your resources coming from your own premises and allow only those to be to access the perimeter and get out the perimeter, which basically having this kind of a context towards who have access to this, who can go through this service perimeter. And you can have this, what we call custom attribute-based access levels, so that you can have multiple different levels of access from the internet for your resources to go through this perimeter. So you can have access from, let's say, a particular device or a device with particular operating system. You can specify, okay, all my company, they're using Windows 2016 patch version this. So I'm only going to allow only those clients to access my perimeter. Anything else is not going to be allowed. Or a range of IPs, for example, or a geographical area, for example. This is where the context that we're talking about here. Anything that is entrusted from the internet is going to be blocked. Anything that not satisfy those rules or properties that I specify, they won't be able to access the perimeter or copy anything from outside the perimeter. And I can configure those, and we're going to see a quick example with that. I can can go to the Cloud Console. I can use the G-Cloud command line tool, or I have the Access Context Manager APIs as well that I can leverage to be able to have what kind of devices I can allow and basically create the service perimeter itself. And this is the Access Context Manager, which I want to be able to have this fine-grained attribute-based control for project and resources. So I put a perimeter around my project, and I put in some conditions. So I can set the access level, and I can set a condition for that. And when the condition is met, based on those attributes, the access is allowed. Otherwise, if you don't satisfy those conditions, you won't be able to log in at all. And those access policies that we talked about, they are based basically on access levels. So the access level, I can specify the IP address. I can specify the device type. I can have control if I know that my company only uses a particular device. As long as if you're not using that device, because I am in control of that, you won't be able to access the perimeter or copy data out. And then you've got the user identity. I can also specify who are my users who are allowed to access this perimeter as well. 4 stages that we're going to have a look briefly now in a demo to create a service perimeter configuration. First of all, you create an access policy and you define those parameters that to allow users that's going to have the this kind of attributes to be able to access your perimeter. And then you secure resources with the service perimeter. So all your resources that are within the service perimeter, that's the configuration that will take place to say, okay, which project is my service perimeter is protecting. And then you can set up, you will set up private connectivity from a VPC network and grant access from outside using access levels. So inside you will have the VPC network who will be part of that basically the perimeter that you want to access, and from outside you will be using basically access levels. So these are the 4 there. And you can also, if you have like 2 projects that are protected by service perimeter, you can get them to talk to each other. I can get some resources from one project or users from one project to go out and access the service perimeter of another project. And this is what we call service perimeter bridge. So you can have them, you can create a bridge between the two, and then they are securely communicating with each other, and you're happy for information to flow between the 2 networks. Let me just bring in the Google Cloud Console, and we will see how this works in practice. Let me just here, if you allow me, just to bring that. And let me just go to console. Okay, that's been logging into, looks like Quick Labs. So I need to access an environment where I have organization level access. So here, what do we see is we need to go to security. Security, there you go. And we want to go to 2 things here that we are interested in: the Access Context Manager and VPC Service Control. And we said we need the Context Manager to be in place. That's going to help us to configure the VPC Service Control. So in here, I select my organization. So a service control will look, a context manager will look like something like this. So let me delete this one here. Okay, because I've got service control that's using this, I need to delete that first. So let me delete this. And now I can delete that. So that was left from my previous demo. Delete that. Okay, let me create. Let me call it DevFest. DevFest demo. Okay, I'll go with basic. But what just to showcase this and see how it works, I'm gonna use the allowed region. So I'm here. I'm based in the UAE in Dubai. So what I will do, I will select that. I will leave it as let me do United Arab UAE, United Arab Emirates. So that's basically this context manager will allow me to access. So if I do that, I'll keep it basic. I can have multiple conditions there if I wanted to with device and device type and OS type and things like that. So for the service control, I'm gonna put a perimeter around my project. So I'm just gonna go a new perimeter, give it a name, the first demo, the project, add the project. I'm gonna add this GCP security, add this one, done. And then the restricted services. I'm gonna restrict cloud storage API. Okay, select that, add that. And for the VPC accessible services, all access level. Okay, create that. Now, if I go to, so I think that's created. If I go to cloud storage, I'm going to open that in a new tab, so we can go back and forth to change the configuration there. I'll select the project. Okay, you can see here that I've got access to that. I've got a bucket here, I can see it. I can access it, no problem. If I go back here and I go to, is this access? Okay, he hasn't created it. Okay, details because of this name. So I'm just gonna call it DevFest. That's fine. Okay, create. Okay, let me go back here to the bucket just to make sure that I still got access to that. Go back, browse. Okay, I can still go and have a look at that. Okay, I'm closing that. What I'm going to do, I'm going to go back to this context manager and I'm going to change that room. Instead of UAE, I'm going to select another country here. I'm going to say, okay, it's not UAE, it's Netherlands. Only allow people from Netherlands to be able to access the cloud storage API inside my project. So I'll put in a perimeter and having control with these parameters to see from where I can have access to that. So if I go back to cloud storage bucket, right click, open in a new tab, and let's see what we get here. Select GCP project, GCP security. Okay, hasn't propagated yet. Let me refresh. There you go. So now you can see, sorry, the server was not able to fulfill your request because that basically is not coming from. If I go back just to make sure that the settings, go back to browser. There you go. I won't be able to do that. So if I go back here and I'll revert back to UAE, okay, save. Give it a few seconds and refresh the storage. There you go. I've got access to my bucket as well because I'm coming. Oh, it's not consistent, but let me refresh. Just a browser update. Yeah. So you can see here I've got access to my storage bucket now because I'm satisfying the context manager property that I'm coming from the UAE. So I can go here and access the cloud storage API. That's all I've got for you. Hopefully you find this useful for your security use cases, just to how to control, how to use VPC service controls to protect the data that is in one of those services that are not VMs, so I can't control them with the firewalls and things like that. So you put a perimeter around it, and then you have control with the different context manager rules to be able to have that control. Thank you very much for being with us. Enjoy the rest of the sessions, and see you around. Bye bye.
Welcome everyone to this session where we are going to talk about streaming data with Google Cloud and specifically with the tools Dataflow, Bigtables, and compute instances. But first of all, let me introduce myself. My name is Levi Orta. I'm originally from Spain, but I'm living in Hamburg, Germany since 9 years. I work for Test Systems International. Test Systems is a subsidiary of Deutsche Telekom. And the system is also premium partner with Google. That's important because it's the highest partnership that you can have with Google. I certified as a data engineer, professional data engineer, and cloud architect. And I have been working with Google Cloud for the last 4 years. And before I was working as a developer. But my current role in the system is cloud architect. My current role is to develop internal tools and services that will be used later for the customers, and also support the customer with consultancy and helping them to achieve their goals, architecture, creating proof of concepts, and so on with Google Cloud. In my previous role, I was data engineer, and I was working mainly in a company that was also partnered with Google Cloud, in Google Cloud and in marketing, and I was working with big data product. And the talk that we are going to have today, it's focused mostly in that tools. So when you are working with big data in the marketing landscape, you work normally with PubSub, Composer, because you need to orchestrate certain pipelines, Dataflow, BigQuery for sure, and in some cases also Bigtable. No? But let's talk a bit about you. Who is the people, the audience that could be interested in this talk? No, I will do it like somehow like basic, so the people that have no experience working with Google Cloud can follow the session. I'm going to talk about the different menus and options that you have in Google Cloud in the console. But also when we are talking more about the code and going a bit more deeper, it would be nice if you have some previous experience working with the platform, with the G-Cloud command, and yeah, you know how to move a bit in the platform. Okay, but then let's start with some explanation of the different tools and services that we are going to use. Well, right now we are here in the Google Cloud Console. We have a project that I created for this session. It's empty right now, and I would like to show you the different sections that you have in Google Cloud Platform. So at the beginning here in the pin section, you have the services that you use more frequently. You can pin it and have it here more handy. Then you have different sections here, compute, serverless, and I will show you specifically the big data section. I will give you some introduction about the product. For example, Composer is an orchestrator tool. If you have different workloads, service, or I don't know, pipelines that you need to orchestrate, it's a great tool for that. Dataproc, if you work with Apache Spark job or you with HBase or something like that, probably you will need to use it. PubSub is one of the key services in Google Cloud. It's a messaging system. You can push messages and it has almost unlimited capacity. And then you can connect different products to PubSub and collect and retrieve the data. Dataflow, I will talk a bit deeper right now. Then we have here BigQuery, that is somehow, it's not really a database, a data warehouse. It meant for analytical purpose. Why it's here in big data? I think it's here because mostly it's used with big data products. And it's not a proper database. The way it stores the data is not really like a database. And then we have Data Fusion. Probably you will need also to use it depending on your developer skill. You can achieve basically the same with Composer, but Composer is more developer oriented. You need to write more code, and Data Fusion is more user friendly and drag and drop, and you can somehow achieve similar stuff. But let's talk right now about Dataflow. What is Dataflow? Dataflow is basically the service that Google offers to you when you want to run Apache Beam jobs. And I will talk about Apache Beam right now. But it's like a service that helps you to run the job. You don't need to do basically anything. Dataflow will spin up the machine when you want to run the Dataflow jobs. It will take care of security, spinning up the machine, shutting down the machine, controlling the communication between the machine, networking, security, everything for you. Okay, so you only need to say, okay, I want to run this job in Dataflow, and Dataflow will take care of the rest. Okay, and I say Apache Beam. What is Apache Beam? It's an open source project. You can write your code to process streaming and batch data, and that is quite important because with the same code you could process streaming and batch. Okay, you don't need to change your code. Clear example: if you have, for example, collected log data, log files for a long time, and then you have a bunch of files and you want to process those files, you maybe want to run a Dataflow job. It's a specific job that will run once to process all the files, okay? And then once you have the code to process the logs file, you could reuse it to process streaming logs, okay? Instead of saving the logs to logs file, you could continue save it for, I don't know, you want to have backups or something like that. But you can also, for example, push the data to some pipeline, to some messaging system like PubSub or something similar. And then you can connect Dataflow to PubSub, for example, and you have the logs in streaming. And with the same code that you wrote to process the data, the batch data, you could process the streaming data, okay? Because Dataflow, it doesn't matter if the data is bounded or unbounded. If the data is bounded, it has a specific amount of data. You know you have X amount of files, and you are going to process that. This is a specific job. It will start and finish. If you have a unbounded data, streaming data, the data, it doesn't finish, it's flowing continuously. So the job is running continuously and is processing data in real time. Okay, so this is Dataflow. Then another tools we are going to use, it's Bigtable. Okay, Bigtable, it's here in the database section. It's here, and you say, okay, normally, when we are working with big data, we need to collect the data from the source. This is something we are going to do with Dataflow. Dataflow will be in charge of collecting the data. And when the data is collected, we are going to process it. And at the end, when you have the data processed, you need to do something with the data. You want to store it, okay? And depending on your needs, you want to use maybe a different database. In this case, for the use case we are going to use, Bigtable fits perfectly with the requirements, but maybe you want to save it in a different place. Maybe you want to save it in BigQuery, maybe in a different cloud provider. Remember, Apache Beam is open source. It means you are not locked with the code that you are writing. Dataflow is just a runner that lets you to run Apache Beam jobs. But if you have your code in Apache Beam, you could run the same code in a different cloud provider, for example, or using Apache Flink or even Spark jobs, depending, okay? You have freedom there. You are not logged in. But what I say, when you have the data, you want to save it in a sink. In this case, that is the name. We are going to save it in Bigtable. Why Bigtable? Bigtable is a NoSQL database. HBase is based on Bigtable, okay, originally developed by Google. It's a distributed columnar-oriented database, and it has the key benefits that a high throughput and low latency. Okay, it can consistently manage sub 10 milliseconds latency and can handle millions of requests per second. Okay, so high throughput, it means that you can handle huge amount of data in a short period of time, so millions of records per second. And then low latency, it means that you can access the data in a super low latency. Okay, it doesn't matter the amount of data that you have. Bigtable, it will work quite fast retrieving the data. For that reason, it's quite good to work, for example, with Internet of Things, when you are collecting huge amount of data from different sensors and you need to push the data to the database in a short amount of time. So high throughput, Bigtable. And then probably if you are collecting the data in real time, it's because you have the need to do something with the data in real time, and you need to access the data in a fast way. That's why the low latency is super important. And Bigtable fits specifically for this use case, for this requirement. No? And the use case we are going to use is based in a fintech. We are going to visualize some real-time data regarding with different cryptocurrency exchanges. Yeah, we need that. But well, then we collected the data, processed the data, and stored it in a database. But now what? Once you have the data in the database, you need to consume the data somehow. And for that, we are going to spin up a small compute engine, and we are going to deploy a small application, it's a small web server, and run a small dashboard, and we are going to visualize in real time the cryptocurrency status. Okay, that's basically the use case we are going to show. So let's go to the code and get the hands a bit dirty. All right, so here we have a repository. This is what we want to achieve at the end. We want to have a dashboard where we can see in real time the data coming from different cryptocurrency exchanges in real time, and we can see the price, the volume, and the delay in milliseconds from the exchanger to the real time data that we are having. This is the architecture we're going to follow. Okay, different cryptocurrency exchanger. We have Dataflow collecting data from the different exchanger, processing the data, and giving the data to Bigtable. And then we are going to have a small compute engine with a Flash application, web server, and a frontend to visualize the data. Okay, this is how the frontend works. Okay, the Flash application is making the request to Bigtable, and then we have a frontend application running and basically making requests to the packet, to the Flash application. This is how a Dataflow job looks like. We will have a look later, but let's start then with the setup. Okay, I'm going to follow the step that we have here. So first of all, let's define the region, so on and so on. Let's then enable the different APIs that we are going to need. So we have here Bigtable admin, Dataflow, and compute. Nice. Let's then now to create a network. By default, a project comes with a default network, but I'm in the test system organization and we have some restrictions. So the project that we create, it doesn't have the default network. So we are going to create the network. And after that, we are going to create, I will come back later, we're going to create some firewall rules that we will need to connect to different services later for the compute engine and so on, and to allow basically the SSH connection to the compute engine. Okay, so we have the network already. Let's run the firewall rules. Now we're going to create a packet, because when we want to deploy the Dataflow job, we need a packet because it's where Dataflow is going to store basically the code. We're going to create then a bucket here. Let's create the compute instance. And once the VM is created, we want to connect to the machine. We are going to create via SSH. Okay, we have here the command to connect to the machine. Okay, and we are now in the machine that's called crypto driver. Okay, good. Let's clear the screen. Now, the first thing we need to do is to install some package, okay? So let's run this. We want to make a sudo, we want to then update, and maybe it takes some time. It seems we have everything installed right now. Good. So next thing we are going to do is to create the Bigtable instance. First, remember we are in a new machine, so I need to export the project and so on. Project, this one. And now I'm going to create a Bigtable instance called create real-time, and we are going to create also a table. Let's run this command to create the Bigtable instance. To see that create a Bigtable instance is quite easy. And now we have the instance. I want to create that table. Okay, create the real-time. Good. Okay, nice. So until here, everything is clear. I want to show you right now what we have created so far. Okay, so here we are here. You can see we created a default network with different network. Okay, I think we are using Europe West 3. We created also some firewall rules that will let us to connect to the VM in the port etc, for example, what we are doing right now. I think we created also some compute engine. So I will show it to you. It's the VM where we are right now. The name is crypto driver. It's here. It's the machine we are connected right now. And if we go here also, you can see we will have a Bigtable instance in database Bigtable. We should have here as well one instance, okay, crypto real time. So this is what we did with the commands. Right now, I'm going to clone a repo that I have. It's the repo that we have here. So this is what I'm going to do right now. I'm going to clone the repo, change to the repo, and now I'm going to build the Java application. Okay. And this Java application is what is going to launch the Apache Beam job. Okay, we will show you later the Apache Beam job, the Dataflow jobs. But right now, what we're going to do is to build the application, and then we will launch the job. All right, you can see that the build is a success. We have the code ready, and now we can launch the Dataflow job. And this is triggering a Dataflow job. So if we go now here, one nice thing about this is you can go here and search for the product, but if you don't know exactly in which section is the product, you can just type here Dataflow, and you are directly in there. Okay, if you click here in running, you will see the jobs that are running, and this is the job that we just started right now. Okay, so the job is running, and now we can have a look, and you see here, okay, and we have here different options. So for every exchanger that we are going to have one pipeline, so Bitfinex, Gemini, and so on, and for everyone is collecting the data, processing the data, basically is extracting the information that we want to store in the database, and then it's writing to the database, okay? So the job is running, and I think right now what we can do is to create the front end, okay? To deploy the web server, and then launch the dashboard, okay? So for that, I think we need to create a new firewall rule, and after that, we can just add attacks to the compute instance, because the firewall rule it's only for the target tag. So we need to tag the VM with the correct tag to apply the firewall rule. Okay. And now we are going to deploy basically the application. Okay. So we are going to change to the front end, pip install the requirement. Remember, we have pip virtual m cd front end. We're going to install requirements of the package, And now I'm going to launch the Python application. That is the web server basically. Okay, and the application is running. If we want to check the application, we need to know the external IP of the web server. This is what we are going to do right now with Compute Engine VMs. We can come here and check the IP address. So we have, so if you have a look, when you run a Dataflow job, Dataflow creates different VMs for you. So this one are the ones that are created by the Dataflow jobs. This is the one that we created, okay? And this is the external IP that we need to use, okay? So, stream. And we see here the frontend, okay? And we will see here more data coming. So the data, the application is working, the Dataflow job is collecting the data in real time, and we can visualize the data here that is collected, okay? When it passes some time, we will have more information here, okay? And different. So we have now for Bitfinex, but we will have here more information. You see right now, I think the Bitcoins, it's around $59,000, okay? More or less. We will see later that we have here more information. Let's go back and look to the code. And for example, the important part of the code, for example, here is when we want to run the Dataflow job. This is in Java. Apache Beam lets you to write code in Java. Originally it was developed in Java, but now it supports Python and also Go. So this example is in Java. I personally prefer to execute it in Python, okay? But here is where you have the main function. And here you can see, for example, for every exchanger, we have here the definition. And then at the end here, you see that we are creating here for every exchanger that we have, we are creating like the different stage. We want to have also a look to the front end. This is a more Python application, as I say. You have here the stream data, the stream route that we just accessed is basically calling to the front end, to the JavaScript. And then the JavaScript, it's making requests to this other get streaming data. And I think every half second is making a request to this. Okay, every is an Ajax call, making a request to this path every 0.5 seconds and collecting the data. And this is basically querying the data, and querying the data, it's making a call to BigQuery and so on, and collecting to BigQuery, sorry, to Bigtable, collecting the data and showing the data in the front end. So let's have a look to the front end. I think right now we should have more information. So you can see here that we have more data coming up. You can see here the value of the cryptocurrency in real time. You can see here also the volume, and you can see here the latency. Okay, so you can see that the latency is below 1 second. That's all for my part. You can extend this code to connect to different providers and so on. The code is in the Google Cloud repository. I think it's here, Google Cloud Platform, Professional Services, and then you have example crypto real time. You have the code here. I did some small modification, but nothing big. And if you want, you can have a look. All right, I hope that you enjoyed the session. And yeah, thank you very much for your attention.
Welcome DevFest 2021. This part of the talk, let me describe how we help an imaginary big company to move into the cloud. Meanwhile, please do not forget to ask your questions on menti.com. The code is 57 82 91 85. And during this presentation, you can find the answers on the event website. So let's start with the aim of my short talk here, where I'm covering the motivation for big companies to move into the cloud, what are their difficulties they are facing with, how the technology can help them, and what processes they need to adapt or change, and what is the solution concept from our side what can work for them. And on the other hand, I'm not going to talk about the startups and small companies, major changes in the company structure or company workflows, and how companies can be optimized for technology, and any low-level implementation in much detail, because I have a time restriction here, and for that please watch the great presentation from Vitaliy. So, my name is Tamás Szebeni, Cloud Architect from Deutsche Telekom IT Solutions, Hungary, working with the Google Cloud Platform. Let's imagine about a hypothetical company called Container Shipping Company, who provides worldwide services in shipping and logistics. Imagine that this company has many offices and subsidiaries for connected services in the supply chain of strategic partners worldwide, and it wants to further grow and identified moving into the cloud late is better than never. Here you can also see some of the characteristics of this company which are important for this migration. Like they want to further grow and seek for opportunities extending their current business, and they understand that they need to invest in providing better service and optimize operation. So we also have strategic statements from Director Board which emphasize the key focuses why they are moving into the cloud. Like existing approval processes and company policies should be enforced, meanwhile order process for the cloud access should be requested, and budget management and splitting the bills are also important features, and for the operation, the monitoring and doing predictive analytics for smarter asset management are must-have features. It is also important to understand the motivation of people working at this company, as without their motivation, the cloud initiative cannot be executed. We are looking at three important departments within the company, where the IT department is motivated to work with the cloud technologies, as they do technology with heart. They really want to optimize slow processes and eliminate any manual tasks they are doing at the moment. In operations and maintenance, there are workers, repairmen and crew of cargo ships, warehouses and truck drivers who wish they can drop paper-based administration and they don't need to wait, for example, 2 weeks for parts delivery. And the third team means accountants, managers and salespeople who does business operation where they wish they can get instant insight into performance markers and can make decisions based on accurate and more data so that they can find new ways to do business. Meanwhile, we understood the motivation, we need to collect the non-functional requirements as well. Based on the information from Director Board, discussions with teams, and analyzing the existing processes, we identified this long list of requirements we need to fulfill. The next step is to find an ideal way for migrating the company into the cloud. And one of the possible solutions can be building the foundation within Google Cloud Platform together with the client, define their configuration based on best practices and recommendation. Define landing zone where standardized project can be provisioned for teams to use cloud resources, build up reference architectures based on the current solutions the company hosts on-prem, and define new processes for cloud together with the client, and finally build self-service functionality to assist teams during their daily work in cloud. These actions can be implemented in several phases involving some of the teams and can increase the cloud adoption rate. There are several new team roles we can also introduce as we need to ensure control and capability at the same time. For example, in the middle, the solution consumer teams, they are who wish to move their current workload into the cloud and choose from existing templates to execute their production workload or build up their solution as proof of concept first, and once it is ready to be assessed, it is handed over to the solution provider team on the left. They are also the team who already has great knowledge of the tools, the technologies and the platform itself. They perform code review, ensures automation and configuration capabilities, validates disaster recovery concept, ensures operation activities are supported and documented, so the proof of concept architecture can be released to be an official reference architecture within the company. The solution provider team also provides consultancy service maintains the existing version of reference architectures, operation toolbox, and offers the reference architectures to the solution consumer team. And however, an operation team already exists, but they need to be extended or educated to operate foundation and workloads in Google Cloud Platform. Let's also talk about foundation and its purpose. To meet specific functional or non-functional requirements like security, government regulations, and opinionated configuration of platform need to be established where access is provided with controls, ensuring the fulfillment of those requirements are always met, that we call as foundation. The building blocks can be the list you can see here, and for implementation you can utilize the Cloud Foundation Toolkit or implement your own if it does not fit the company needs. On the other hand, the landing zone is the next abstraction. While foundation ensures the controls over all the cloud resources, the landing zone provides the access per team, so the isolation is guaranteed. When implementing a landing zone, usually it means a folder where the projects for the team is provisioned, with IAM access provided to the user group in Google Workspace or Cloud Identity, or formerly called G Suite. And that project usually receives a shared VPC for central networking and a budget alert for monitoring. And one such Terraform module within Cloud Foundation Toolkit, I have a link here, which is the G Suite enabled project factory. Talking about the next abstractions from the pyramid, the reference architectures. They are the standard solutions to specific use cases, like moving from general purpose to company specific. The list you can look here. For some examples like hosting static websites, application hosting, analytics, so on, to do the company specific entries like predictive analysis for plant maintenance, route optimization for all transports, warehouse optimization, and also the tracking 2.0. But this is nothing without the processes we need to introduce. For example, there is a company requirement to have a process around requesting cloud access, requesting exception process, for example, in cases when there is a deviation from reference architecture or there are some restricted feature that a team wants to use. Also, converting the proof of concept to reference architecture that can be done by such a process. Request consultancy services and budget for cloud resources and cloud usage, and also requesting project and also offboarding a project. And finally, at the top of the pyramid, the self-service functionality to support client teams to perform self-administrative tasks in a convenient manner, such as managing their users for their projects, reconfiguring budget alerts, requesting a restore from a backup, and doing permission elevation for emergency situations according to the breakless scenario. And finally, to provide the technical background for Cloud Foundation, let me talk about them in very brief. The identity management usually involves the cloud identity or Google Workspace, where we can require two-step verification, configure SSO, and manage teams as user groups. The baseline or the bootstrap within Foundation enables the landing zone in a secure and fully automated way. Technically, it has several pipelines, only one purpose for each. And to ensure hardened security features are established, billing automation, infrastructure testing, and operation toolbox implemented. And to enable GitOps approach, a dedicated Git repository for code and CMDB. Let's hope the best for our container shipping company. Thank you for listening. Let me pass the stage to my colleague who will talk about private catalog solutions. Thank you.
Welcome to the DevFest 2021. I'm Kristóf, Helmrich, Cloud Architect at Deutsche Telekom IT Solutions. In this session, I would like to present the private catalog service on GCP. You can ask your questions on dementi.com with the code 57 82 91 85. They will be answered afterwards on the event webpage. We will start with a high-level overview and check the workflow, compare the private catalog and cloud build. We will check how solutions can be customized, and I will present you a short demonstration. And finally, I will present you the documents and sources that I use for this presentation. So let's start with the product overview. Actually, private catalogs can be split in 3 parts. First of all, the catalog is a collection of solutions. It can be published on organization level, on forger level, or on project level. Solutions are written in Terraform or Deployment Manager format. They can be assigned to one or multiple catalogs. Deployments are the solutions which are deployed on the customer project. With private catalog solution, we can control the distribution on which level we want to share the solution for the customers. From customer point of view, he can find all the available solution in his project. And with the private catalog, we can make sure that all the company restrictions in regards of compliance and governance can be followed. There are 3 types of solutions available in the private catalog. First, the deployment manager-based solutions, which can be written in Jinja or Python. They can be customized with schema files, and the code can be uploaded directly to the solution. In the background, the deployment manager will run to execute the solution. The second one is a Terraform-based solution, and in that case, the code can be uploaded directly to a cloud-based storage. In the background, the cloud build will be executed to deploy the solution. The third one is a link-based solution, which is a simple reference to a solution documentation. Let's have a look on the workflow. First of all, we have to write a code in Terraform on Deployment Manager solution. Then we have to compress the code in a zipped format. We have to upload the code on a cloud storage in case of Terraform deployments. In case of Deployment Manager templates, it can be uploaded directly to the solution. Then we can create a new solution. As a catalog admin, we are able to create new solutions. We can assign the solution to a catalog, or even we can assign to multiple catalogs. And as a last step, we can share the catalog on the different level of the organization hierarchy. From customer point of view, he can select the solution what he wants to deploy. He can set parameters to customize the solution, and he can start the deployment. Comparing private catalog with cloud build. From code point of view, private catalog can use Terraform, Deployment Manager templates, or a simple URL. Cloud build can use Terraform, Python, gcloud, or anything which is possible to run in containers. Private catalog solutions can be triggered manually, while the cloud build has more flexibility. It can be triggered by pull push events, webhooks, or PubSub. Deployments are managed by customers in case of private catalog. For cloud builds, it's mostly managed by the admins. Private catalogs are shared on organization level, forger, or project level. For cloud build, it is only a single project where the cloud build is running. The scope of the private catalog is the project where the deployment will be executed. For cloud build, it can be outside of the project. It can be a different project, forger, or organization level. We can customize the solutions what we want to use, and for that, here you can see an example for Deployment Manager-based solution. On the left side, there is a schema file, a part of the schema file, where you can see that with the properties and with the default values, we can customize the solution what we want to publish for the customers. On the right side, you can see what the customer will see. He will see that kind of input form. So, let's start with a short demonstration. I will create 2 catalogs. For the first catalog, I will create a solution which is a DM-based solution. And it will contain a compute engine with a Debian 9 base image, and it will be shared only with the project A1. For the second catalog, I will create a second solution, which will be a link-based solution. It will be published across the whole foliage structure. Okay, let's jump to the console. Okay, first of all, let's open the private catalog admin page. Create a catalog. Let's call the first one DevFest 2021 private. Create a second one. It will be the public one. Let's go to the solutions. Now I will upload the deployment manager based solution here. But let's name it first. And I can browse for the prepared code in a zip format. Okay, that's done. Let's create the second configuration, which will be the link-based solution. I will call it doc presentation. And for the URL, I will use my GitHub source, what I used for that demonstration. Okay, once that's done, I can assign the solution to a catalog. For the documentation, I will do it as a public one. And for the computation, this will be the private one. Let's go to the catalog. Clicking on the private one, and I can share it on the only with the project A1. And selecting the public one, I'm going to share it with the whole foliage structure. Okay, that's done. Let's go to the project. First of all, the project A1. I can select the private catalog page. Here we can see that both solutions are available here. I will select the compute engine. And I will give the name test. And for the VM name, I will put some name here. I will keep all the default values here. Okay, in the meantime, I will switch to a different project. Okay, let's switch to the B2. And here also I can select the private catalog. As we can see, only one solution is available because with the whole foliage structure, only that solution was shared. And here you can see it's just go to link. If I'm clicking it, it's following, it will open the GitHub page with the source code and documentation. Okay, let's go back to the deployment manager based solution, and it's already done. Now we can check the compute engine if it's already available or not. So it was called test dn 001 minus VM. it's already available. That's all. Okay, for all the documentation and resources that I used for that presentation, you can see it on that page, and you can find also the source code on the GitHub. Thanks for watching and have a nice day. Bye bye.
Hi, my name is Vitaliy Zhhuta. I'm system architect and I'm helping companies with the technical challenges. I believe you have heard about the software patterns and anti-patterns, but are you aware that those things apply to the infrastructure as a code? DevFest Budapest 2021, I'll be talking about EAC, patterns, anti-patterns, Terraform and other exciting things. Hello, my name is Vitaliy Zhhuta and I'm going to talk about the patterns and anti-patterns in infrastructure as a code. For the beginning, let's figure out what is the pattern and what is the anti-pattern. Let's start from the anti-pattern. Anti-pattern, it is insufficient, ineffective and counterproductive. We don't use those things in a regular basis, but sometimes we are forced to use things to solve some kind of problem or some kind of issues. But what is the pattern? If you take a look on the nature, we can see a lot of different patterns. Let's look on the seashell. Here's the plant. Here's the galaxy. They are different things. Nature has bring to us different things, but they have something in common. They have something that makes them look like each other. And what is this? Scientists trying to figure out what is this, and they come up with Archimed's spiral. So we actually can describe this pattern, this spiral, with the equation, and that helps us to repeat or actually figure out if this is applied to any other things. I don't know, solar system maybe. So one of the possible things to describe the patterns is the equation. The same thing we do in real life, I mean in IT, when we are trying to describe the infrastructure. So we simply use some kind of equation when we are describing. But let's stick to the equation. We all know this very similar formula for velocity, time and the path, but physicists make this formula really complex. This one we can see in the theoretical mechanics when we have a different speed over the time. This one is even more complex, and the last one is actually from the quantum mechanics. All of those things are really start with a simple or actually start with a really complex and can be each other. So you see, same problem has a different description. People actually very often do a mimicry. So what this means in IT, let's see, tree. How we actually mimic this into the IT. I don't know who, but actually someone a long time ago done a really nice things about that. File system, tree file system. We can see this tree file system in Unix system actually from the very beginning. So one of the things when we speak about creating the patterns, it's mimicry. We're taking something that exists in a real nature and bring this to our world of IT when we're doing something or solving some kind of problem. Sorry. Let's speak about the infrastructure description. What is the possible way to describe the infrastructure? I was looking through the internet and was trying to find who actually used this approach to describe the infrastructure as a code, but nothing comes to my siege. But actually I can think about one thing. etc hosts. We know that this etc host, this file actually exists in every single operation system, in Unix, in macOS, in Linux, in FreeBSD, even in Windows. This file is really simple and was invented like maybe 40 years ago, about to describe which IP address has which human readable name. It's great. You don't need to remember the IP addresses. It's more complex, but you simply remember the names. And humans are good at remembering names instead of the numbers. But does we keep this simple? Maybe we make this more complex? Yep. We did this with the bind. And here's the description of the example.com. So we put somewhere in internet the name service that has this description of correlation between IP addresses and the names, and we don't need to update our etc host each time new hosts appear in internet. So we simply have the two records in our system that point our computer to the DNS system, and we can reach the information about the host. Do we accept it is like very simple description of infrastructure? Once in my career, when I was working for a company that builds private and public clouds, I was support engineer in that company and was supporting the infrastructure for the clouds itself. And I have some tasks when I need to maintain numbers of hosts. So I created very simple inventory file. Here in this file I have the description of IPMI interface and its IP address of the host, and the human readable. It was solving my problem for some period of time, but the maintenance task grow. I have a different task to do on those hosts, and then I meet the Ansible. An Ansible inventory file. So we actually do the separation. We write the roles, playbooks, that doesn't contain actually the information about the host and can be reused. So we go and apply the principle try, don't repeat yourself with Ansible. And Ansible inventory file plus Ansible playbooks and roles also is the description of infrastructure. But it's not like a code in way we are thinking about the coding. More close example about the coding, and when we have an if statement, we have the for loops, to my opinion, was the Vagrant file. When we describe our infrastructure with the Vagrant file, when we specify how many, which image we have to use to build the virtual machine, what the IP address is going to be, what the size of the trees, or what the size of the RAM, we can actually do that. After the Vagrant, we see the Terraform. And Terraform right now is really a great thing that helps us to describe the infrastructure. Keep in mind that Terraform is a declarative language. HCL is a declarative language, and Terraform declaratively describe the resources that we would like to have in a cloud. But I would like to bring to your attention how we actually structuring our infrastructure as a code. And it will be our very first pattern. The structuring, or actually separating the different resources in a code. I believe you have heard about this approach, tree, balcony and helicopter view, but could it be applied to the infrastructure as a code? Yeah, sourcing the Terraform code. And let's start from the very easiest, tree view. It's actually a simple one. Imagine that you are on a tree and how far you can see from the tree. Is it far, really far? No, you see like 5 meters, maybe 20, maybe 100 meters around you. That's enough. And let's call this simple. So simple way how we are describing our infrastructure. We have one single Terraform file where we put everything. We put the description of Terraform bucket, Terraform provider bucket, maybe credentials, some resources, and actually keep the TF-vars files nearby. That's all. We don't need any other files. It's really simple. But as soon as you have a lot of resources, this file can grow and it can have multiple lines, 1,000 lines, for example. It will be really easy to maintain this file? No. You will say definitely no, it's not really easy to maintain this file. So we actually come up with some advanced tree view, but advanced. What is advanced? So we actually take all those resources and put into the different files. Then when you simply cd into the directory, you simply see that you have a backends, a separate file, compute resources separate file, database are in a separate file, networking, you actually have output, providers, variables. It's easy, but it's still this tree view and a bit advanced. Could it be more advanced? Yeah, I call this advanced plus. When we have models and we're using the models. I wouldn't explain to you what is the Terraform models, but it's really nice way to keep the dry principle. You don't repeat yourself. You actually come up with some pattern. Okay, here we speak about the pattern. We convert this pattern into the Terraform module and put this Terraform module in some repo. It could be stored in the same level as our code, called the directory models, and in this directory we create more models that has its own models. But that is still tree view. We are not looking so far. Next level is the balcony. Imagine that you are living like 16th floor, 20, maybe higher, and it's going to be advanced plus. Advanced plus, what it could be? Yeah, multi-cloud. So we actually have a multi-cloud description when we have a Terraform and we have a different clouds, we have a different models that act to the different, correspond to the different cloud. Yeah, that is advanced plus plus. Is it enough? No. We actually create even more complex infrastructure, architecture. We're not talking right now about a single project. We're speaking about the multiple projects. Well, talking about the GCP. GCP has its own organization and we actually can describe everything. And it's helicopter view. Imagine how far you can see from the helicopter. It's really far from you. So advanced plus, 3 pluses. When you are describing your organization, you're describing the actually mimic your business unit into the organization. You have the folders that corresponds to your business units. Each business unit can have a different organization policies, different networking, different sets of projects, and it's really describing the whole organization. But here we have to keep one thing in mind. As soon as we have this tree view, balcony view, and helicopter view, we have to care about the separating the code, separating of duties. We cannot mix everything, like take the helicopter view and put everything into a single repository. Projects, networking, organization constraints, EAM binding. Yeah, it's possible to have, but imagine how it would be complex to maintain a huge numbers of code into the single repository. So my suggesting, and it's going to be another pattern, separating of duties and how we actually store the code. Tree view is simple Terraform model or pattern. In our case, pattern, it could be a combination of different models. or even model can combine different resources into some kind of the pattern. Then balcony view, project level. So we have like in GCP or in AWS, what we will, well, logically do a logical constraints, logical boundaries around the resources, and let's call this project. In GCP it's really easy to call this project because projects is actually isolating of the resources. Even the VPC exists in the project. We can have multiple VPC in the project. Yeah, project, functional grouping, BU, maybe our project is solving some business domain issue and some business unit is using this. So project level resources, functional grouping, business domain grouping. Helicopter view. Helicopter view, we simply describe the resources that belongs to the organization. Like networking. We don't want that if we are having a huge organization, and we don't want that every single project in our organization manage the network for its own project on itself, and we would like to have centralized managing of the network. So we put the network management under the organization, security constraints under the organization, EAM bindings, etc. under the organization, and projects, those shells for resources, we also put under the organization. So we can make a statement here. If we are talking about like module, we keep this in a separate repository. Well, you may ask question, should we use the same repository for many modules, or each module its own repository? It's up to you. It's up to your decision. Both ways are possible. Balcony, when we store the project resources on the same Git repository. And helicopter, when we simply separate the organization and the description of organization, storing in a separate repository. Yeah, so is it any way to make it even more simple to manage it? Well, we have a different repositories. That's great. We have managed this separation of duties. That's great. But how we actually can make it life more easy? The automation for patterns. Imagine that you come with the idea, well, in my case it was like how you actually can provision automatically project for organization. So we create the module that actually create the project, bind the EAM roles, set the networking, set the security constraints, and then we can give this project to the users. So we come up with some EAC pattern that describes some small piece of infrastructure. What we have done, so copy pasting this code from one folder to another is not, and changing the variables is not really things that humans needs to do. So we actually convert this into the Jinja template, write the code builder microservice, upload this Jinja template to the code builder, and give the interface to the users. So the users can actually call the API of the code builder. Code builder will take this Jinja template, take the values that was provided by the users, and based on this generate the Terraform code and store this code in a code store in a Git repository. Then on the right hand of this, we will have a CI/CD pipeline that will take our code from the store and delivers this into the cloud. So actually create the resources. And I would like to show you a demo for that. Just do our demo. I will bring our one of our slides that will explain us what is going to be this demo. At the center of this flow, or we actually have a code builder, and in our case, it's a Python application that will takes the Jinja template, takes the inputs from the user and generate the Terraform file. So let me launch this application. Okay, we have launched it, started. Let's check if it's working. Get to the Postman and let's take a look if we have any kind of models. We have README, but it's actually empty file just to make sure that our microservice is working. And let's try to upload our Jinja templates to our microservice. So here I have at least 4 different templates, Jinja templates around the modules. Very fast one is about the bucket. Second one is about the Cloud SQL. Third one is about the compute, log sync, and the service account. So let's start from the bucket. To upload the templates to our microservice, I will use the curl. Let me find it from my history. Okay, sorry. Oh, I have a lot of those things. And very fast one about the bucket. So I'm running this from this directory where we have all these templates. So I'm passing to this URL template file as a file and the name of our template. So run. Okay, we got the reply that bucket has created. Let's see it through the Postman. Okay, we have a bucket. Let's do next thing for the compute. Compute. Oh, sorry, I made a mistake with double P. Let's delete this one. So delete templates, and I will simply need to provide the name of these templates. The rest is not important to us, so let's Command E and delete all those things. Okay, we delete it. Let's fix it. Compute, upload. We upload it, check it through the Postman. Okay, we have a compute, so if I just take this one, put it here and send the compute, I will get this reply about describing our template that we have uploaded. We have the template itself and the variables that could be accepted by our microservice. Let's launch the user interface. So this one that I was showing you is like admin interface where we are uploading and managing these templates. But what if we give the interface for the user? And I have a small UI application. Start. Let's launch it. Okay. Open. Yeah. Okay. I see the bucket, age, life cycle, member, name, team. This is our input parameters. Let's check for the compute. Okay, disk size, image, machine type, name, server type, subnet type, team. That's nice. Let's add one more template. Let it be log sync. Okay, just our command log sync, and here we need to change to log sync. Done. We have added. Checking through the UI, reload. We have the log sync. Yes, as you have seen, all those three resources have pass commit message, but other input variables changing. So pass, it will be Git repository where we would like to store our generated Terraform file. I have this prepared EAC pattern in anti-patterns repo. Going to copy the path to it, installing the path. Then I'm specifying the folder, or actually path, where I'm going to put this file. Org folder 1 project 1. What we're doing, log sync df commit message, referring to the ticket number and the message for edit log sync to app project 1 dataset log data set filter. I have the example of the filter here. Resource and varn name, my family name, log sync, organization 1 2 3 4 5 6 7 8. It's just for the example. Project 1, scope limited, and let's submit it. It will take some time. Okay, it has create new branch, and if I go here and simply reload, I will see that it creates the new pull request. Cloud 1 had been recently pushed less than a minute ago, so I can compare in pull request. You see, this is our generated Terraform code. So, and as soon as I just create the pull request, it creates a new branch, cloud 1 2 3 4, and it added the log sync with this message that we have been pushing. Like this commit message. And other part, as soon as I just approve it and launch the command, it will merge the request to the master, and our CI/CD pipeline can be launched and deliver these resources to the cloud. This is the example of our microservice. If you would like to know more about this microservice, we actually have this uploaded to the Git thanks to the Bogdana Kuzmenko, who is actually our Python dev and create a lot of this Python code for this microservice. We will outsource this soon, so you actually would be able to help us to develop this microservice. Thank you for your attention. Nice to speak to you.
Hi everyone, it's Péter Ripka. Thank you for having me. I'm a BI consultant at DXC Technology Hungary, and today I'll give you a brief overview of Google Cloud's Vertex AI. In May earlier this year, Google Cloud announced Vertex AI at Google I/O, Google's annual developer conference. It was a bit unusual announcement since I/O tends to focus on mobile and web developers and doesn't traditionally feature a lot of Google Cloud related news. I know some of you might think that you've had enough of the hype surrounding Emma during the last few years. And you're probably right. As we can see, both of the topics of this presentation are on a downward slope of the peak of inflated expectation known as hype. Also, a common problem among data scientists, machine learning researchers or engineers is that putting a model in production is quite a challenge. As a result, some claim that a large percentage, around 80% of models, never see the light of the day in production. According to certain reviews, the vast majority of companies are either investing or are interested in investing in machine learning and are not getting value from it. Craig Wiley, the Director of Product Management for Google Cloud's AI platform, said, "Ultimately, our goal with Vertex is to reduce the time to return of investment for these enterprises, to make sure that they can not just build a model, but get real value from the models they are building." So trust me when I say Vertex AI is worthy of your attention. So let's get started. Vertex AI brings together the Google Cloud services for building ML under one unified UI and API. In Vertex AI, you can now easily train and compare models using AutoML or custom code training, and all your models are stored in one central model repository. It allows developers and data scientists across skill levels to quickly train, evaluate, and deploy ML models. In this single environment, you can move models from experimentation to production faster, more efficiently, discover patterns and anomalies, make better predictions and decisions. According to Google, it takes about 80% fewer lines of code to train a custom model versus some of its competitors. It supports all open source frameworks such as TensorFlow, PyTorch, scikit-learn, you name it. You can access it multiple ways, with user interface, Google Cloud Console, API or SDK. Vertex AI is generally available since May. Vertex AI covers the entire ML lifecycle of your model, starting from data ingestion, defining and uploading your dataset, data labeling to training and evaluating your model, deploying it to an endpoint and monitoring. You can also store multiple models, manage your models and endpoints, and also set prediction traffic splitting if you want an endpoint to serve multiple models. Vertex AI includes a ton of components. Some of them are brand new and some might sound familiar to you. I'm just going to highlight a few for the sake of this presentation. AutoML enables developers to train high-quality models specific to their business needs, with minimal ML expertise or effort. Vertex AI also has a data labeling service where you can get highly accurate labels from human labelers for better machine learning models. The Feature Store is a fully managed rich feature repository that helps its users serve, share, and reuse the machine learning features. With VZA, you can automatically optimize hyperparameters for maximum predictive accuracy. With explainable AI, you will understand and build trust in your model predictions with robust, actionable explanations. Model monitoring lets you set automated alerts for data drift, concept drift, or other model performance incidents which may require your supervision. You can also build pipelines using TensorFlow Extended and Kubeflow pipelines to streamline the end-to-end machine learning workflow. Okay, so there are a few important questions to answer before you decide which component do you want to use for your ML problem. For example, do we have the necessary data to train our model or not? If not, then we can use Google Cloud's pre-trained APIs for vision, video, natural language, and more. You can easily infuse ML into existing applications or build entirely new intelligent applications across a broad range of use cases. Then, we have to decide whether we have the expertise to write the model code ourselves. If not, then AutoML has our back with a centrally managed registry for all datasets across data types. Or, we can write our custom model code ourselves if we have what it takes. Okay, so here we are at the Google Cloud Console. You can either use the search bar at the top to look for Vertex AI, or you can use the hamburger menu at the top left and scroll all the way down to artificial intelligence. There it is. And then you can pin Vertex AI, so it'll appear always on the top of the menu. And now if we'll click on it, we'll land on the main dashboard of Vertex AI. Okay, let's take a look on the left side for a moment. You can easily access the most important components from this menu. We haven't used all of them, but I'm going to show you the ones we've used. First, of course, the datasets, the fundamental part of every ML solution on Vertex AI. You will see all your managed datasets listed here. We haven't used the labeling service or the features tab, so that brings us to Workbench. If you remember, the notebooks, previously AI platform, were moved to Workbench. So if you like to work with Jupyter notebooks, look no further. Under Training Pipelines, you'll see all your models, and if you click on any of them, it'll take you to the Models page, where you can see all the evaluation metrics of your model. Under Endpoints, you will see the previously created endpoints. Remember, these endpoints are necessary to deploy your model so you can use it for prediction. And finally, under Batch Predictions, you'll see your previously attempted batch predictions. Now you can see the 4 data types that AutoML currently supports: image, tabular, text, and video. For image, you can choose single or multi-label classification, where the model predicts one or many labels from an image. For example, identifying dogs from images of different animals. I also brought an example for this data type, but more on that later. Second, object detection. Object detection is when the model draws bounding boxes around an image. Finally, image segmentation. It's where a model can assign a label to pixel-level regions in an image. For tabular, you can either pick regression, when you predict a numerical value, or classification, where you predict a category associated with a particular example. We'll get back to this soon with my second example. And also forecasting, when a model predicts the likelihood of certain events or demands. For example, when you want to predict sales over a period of time. For text, you can choose single or multi-label classification. It's when the model assigns one or more labels to an entire document. For example, categorizing customer support emails like complaint, suggestion, billing, and so on. Entity extraction is when the model identifies custom text entities within a document. For example, if you want to identify all the phrases in a customer support email that reference internet connection, like disconnect, lag spikes, poor connection. And finally, sentiment analysis is to understand the overall sentiment expressed in a block of text. For example, to see if a user left a happy or frustrated comment or tweet. Last but not least, with video, you can pick video action recognition. It's where the model identifies clips in the video where specific actions occur. For example, in a basketball game, the action of a player making a slam dunk. Video classification, which provides label predictions for the entire video, shots, and frames. And finally, video object tracking is where you get labels, bounding boxes, and timestamps for objects you want to track in your video. For example, in the same basketball game, you want to track the basketball's motion throughout the video. For the purpose of this demo, I'll create an image classification dataset. First we pick our region. Then we have to select an import method. You can either upload images from your computer or from your cloud storage. After this, you will be able to label your images or request a labeling service. After you are done with labeling, you can check the Analyze tab to see whether Vertex AI has some recommendations to you to improve your model. Okay, let's talk about pricing. In general, you pay for three things: model training, predictions, and any additional Google Cloud product usage. Some of these are mandatory. For example, you are required to store your data and program files in Google Cloud storage buckets during the Vertex AI lifecycle. And some of them are optional, like the data labeling service. Pricing for Vertex AI operations and equivalent legacy operations are the same for each operation. For example, if you train a model using AI platform training, the cost is the same where you train a model using Vertex AI training. For Vertex AI AutoML models, you pay for three main activities: training the model, deploying the model to an endpoint, and using the model to make predictions with it. The hourly rate of training also differs based on the data type. So for example, our image classification training was $3.46 per node hour, while the tabular data classification training was $21.25 per node hour, which is a huge difference. It's also important to know that you pay per node deployed, even if no prediction is made, meaning you must undeploy your model to stop incurring further charges. For custom trained models, it depends on a lot of things. For example, the machine type, how many VMs to use, where you use it, in which region. Also, if you use compute engine machine types and attach accelerators like NVIDIA Tensor Core GPUs, the cost of the accelerators is separate. The cost of predictions and explanations also varies based on your choice of machine. Any additional Google Cloud resource is subject to additional charges. For example, data labeling and model monitoring. We managed to spend only $141 of our initial $300 that came with the trial account. Still, please check the full pricing rates or estimate your cost with the pricing calculator just to be on the safe side. The first example I brought today was actually one of our projects from last year. We also made a dashboard to visualize our findings in Google Data Studio. In this project, we had to consolidate the codebase of several thousand SQL reports. About 1,000 of them were categorized, so we knew the background of the report, who developed it, what data mart it is based on, and so on. About 2,000 were so-called freehand SQLs, meaning we didn't really know anything about them. We used 20 data marts as categories and used hosted complexity measures for SQLs. So in the top right corner you can see the average report complexity by data marts within our datasets based on the hosted complexity measures, meaning the smaller the number, the more effective the reporting source is. As you can see, the freehand SQLs are by far the most ineffective and most complex compared to data marts. Our objective was to examine these reports based on the tables used and try to assign which data marts could be served efficiently. So the main question was, can Vertex AI help us categorize these freehand SQLs? For this, we used AutoML classification with tabular data and used two datasets, one for training and one for batch prediction. As a result, the model gave us a number between 0 and 1 for each of the 20 categories. If you take a look at our model, you can see its evaluation matrix, a confusion matrix, that shows us how often the model classified each label correctly, in blue, and which labels were most often confused for that label, in gray. And also feature importance, which shows you what were the most important features for making the predictions of your model. In our case, one of the features contributed almost 50% to the predicted result. Finally, at the Model Properties tab, you can check the underlying metadata of your model. Okay, let's get back to our nice little dashboard. You can find some statistics about the training and the prediction of our model in the bottom left corner. In the bottom right corner you can see a table with the results. In the first column you can see the freehand SQL's name, and the numbers in each cell represent a score that's based on the used tables within the report. This is the likelihood to implement the report in a certain data mart. So for example, the daily activities and daily sales freehand SQL reports are 97 and 98% likely to be implemented in the daily news data mart. If you've seen my teaser for this meetup, you saw that I was playing with a board game that I'm a huge fan of, Arkham Horror by H.P. Lovecraft. This is a fairly complex cooperative board game with an abundance of tokens and cards, and it has quite a learning curve. So I thought it would be fun to make an AutoML image classification model to classify the different tokens of the game. My colleagues think I'm obsessed with this game, and now that I think about it, so far I made a chatbot to help us with the game rules, a dashboard to keep track of our previous game statistics, and now this model. Okay, I'll take it. To be honest, it was fairly easy. I took a bunch of pictures, uploaded them, labeled them, and trained the model. Later I created an endpoint and deployed the model so I could test it. Okay, let's see this process step by step. After I uploaded the images, I labeled them manually. You can see all the labels in the middle. Assigning an image is pretty simple. You just click on it and assign it to a label. You can choose an existing label or create a new one. You can also assign multiple images at once. Then on the Analyze tab you can see that Vertex AI recommended me to add additional training images. Since I used the absolute minimum amount of samples for training, Vertex AI recommends using more than 100 images per label. In this case, I used only 10 for each. Still, I was able to train the model on it. After the model was trained, I deployed it to an endpoint. After the model had been deployed, I could finally test it with new images. Here you can see the model successfully categorize a Doom token from the game. Okay, to quickly recap, Vertex AI has every ML-related solution Google Cloud can offer. It is very user-friendly, so no worries if you're new to ML. But of course you can customize and fine-tune your ML model if you are experienced enough. AutoML is very powerful and its capabilities shouldn't be underestimated. Personally, I really enjoyed working with Vertex AI and can only recommend trying it yourself by signing up for a free GCP account. Before I end my presentation, first I'd like to thank my teammates for supporting me. So here goes a shout out to Attila, Tibi, Zoli and Johnny. Also, I'd like to give credits to Priyanka Vergadia, a Google Cloud Developer Advocate, and her series on Vertex AI. There is also an ongoing skill challenge campaign for acquiring GCP skill badges, which is free and for a limited time only. If you really want to stand out from the crowd, check out the Professional Machine Learning Engineer certification. This has been our high-level overview of Vertex AI. I hope it was accessible and useful to you. If you have any questions, hit me up on any of the links below. Thank you for watching, stay safe everybody, bye.
Hello everyone, my name is Árpád Jorzsits and this is the panel discussion of DevFest 2021. As you can see, I'm sitting in the studio virtually and I have some exciting guests with me today coming from various companies representing different areas. So let's jump in and start with an introduction round. Dear guest, please introduce yourself in a few sentences and tell us what is the part of your job you like the most? Nabil, if you would like to start.
Yeah, hello everyone. My name is Nabil. I'm a Google Cloud Director Training with Jellyfish. I've been with Jellyfish for a year and a half. Prior to that, I was with the company in Atos, Cloud Architect, Solution Architect. So training is bringing together all my expertise from the enterprise and teaching that knowledge now in the Google Cloud. So which allows me to have this passion to teaching. So most of that I like is sharing knowledge. So bringing all that expertise from being a cloud architect and teaching that in a very structured way with the Google training, that gives me a lot of satisfaction. So that is my driver. I enjoy people discussing this technology from the experience that I had, expertise that I brought into the table kind of stuff.
Thank you, Nabil. It's great to have you here. Levi, would you like to be the next one?
Sure. Yeah, first of all, thanks for having me here. My name is Levi Orta. I work for Test Systems International in Hamburg. I'm cloud architect, and I'm certified in Google Cloud as a data engineer and professional architect. But in my previous work, I was also working as data engineer. So I have a good overview of the Google Cloud. During the last 4 years, I was working mainly in Google Cloud, and I like to focus more in the big data area. And since last month, I'm also working more in the infrastructure as code and so on. So everything related with that, with cloud architecture or big data in Google Cloud, it's my topic. So happy to be here.
Great, thank you very much. Kristóf, if you would like to be the next one.
Sure. Hi everyone, I'm Kristóf Helmrich, cloud architect at Deutsche Telekom IT Solutions. I'm working since 2 years in the GCP project, focusing on landing zone development and customer consultancy. My current project, we are developing a GCP landing zone for a big customer and with multiple brands and yeah, actually multiple departments want to go on the GCP platform, and we are supporting the customer on that way actually. And yeah, we have a great team, and I really like to work together with all my colleagues. And yeah, the best part maybe of my job is to build up something from scratch for customers and give guidance on that way to move to the cloud, actually.
Thank you very much. Vitaliy, if you could continue.
Hi, my name is Vitaliy Zhhuta. I'm system architect from EPAM Systems. I've been in the cloud operation for more than a decade, and right now I'm more concentrated on onboarding clients in Google Cloud, helping them to build solution on the Google Cloud, and actually all things that we can do on the Google Cloud. So this is my role at EPAM System.
Great, thank you very much. Zoltán, if you may continue.
Yeah, hi, my name is Zoltán Vágó, and I work for DXC as a, let's say, analytics architect. In the past, mostly in traditional data warehousing and BI areas, and over the past years in cloud projects, mostly around GCP and sometimes with other cloud providers. And well, the best part, the thing which I like best in my work is really delivering successful data products, which is useful for the business.
Thank you very much. And last but not least, Tamás.
Hello everyone, my name is Tamás Szebeni. At the Deutsche Telekom IT Solutions as a cloud architect, and as having a full stack developer background, my favorite part my job is the diverse set of technologies and technology problems that we are facing with together with the customer, and it's very satisfying to find solutions together.
Thank you very much. If you could speak a bit more loudly, that would help a bit. Colleagues, what a team. It's great to have you here all. And let's continue then with our next question, which is the following. Based on your experience, what do you think, what is the biggest blocker of cloud adoption for companies, for your customers in 2021? Nabil, if you could start.
Yeah, sure. So I had exposure when I was working with Atos, working with different clients. I've got the point of view of customers trying to adopt specifically Google Cloud. Moving into training, I had a different kind of vision to that, different kind of angle of people have these two things. But things that they came up in discussions and things when we give training, resistance to change. So people working on-prem and they don't want to to have new skills. They want to stay in their container, not gain more scales, and then job security as well. They said that the company is adopting change. I need to resist that, the change. So they will put like negative impact on the transformation itself. Cloud is not going to work. You hear a lot of that stuff. Second blocker, you hear a lot about security. There's a big misconception when it comes to security. Cloud is not secure. Have you seen the news of this data being leaked and stuff like that? But it's about the skills, really. People don't know how to use the cloud where you have these security breaches. And all the discussions come around a skill gap. So there is a big skill gap in the market. And that's why there is a lot of drivers around certification and all that kind of stuff. And people don't find the time. So there is kind of companies don't want to give employees enough time to get the skills. They want them to get certified, and the employees, they want to say, I don't want to work on the project. Give me time to learn. So nobody wants to spend time outside the 9 hours they work through the day to learn this, which makes it a lot of kind of contention there, a little bit of challenging, really, because company doesn't give you like 40 hours a week just to go and learn new skills and get certified and things. So it should be a balance between the two. The employees should invest time from their own into that. And the other one is compliance. So people are worried about their data. Where do I pump it? Can I replicate to different country? Can I use that? Specifically around one experience that I had around where it was Brexit. There was a lot of kind of uncertainty there. Solution architects were all over the place. They didn't decide, how do I design that? Brexit is not, the UK didn't make that decision. Can I replicate to Germany from the UK, especially in the financial industry? And this is what led to companies to go multi-cloud in the same countries, hybrid cloud, and things like that. So these are some of the points that basically hindering still the adoption and the kind of the speed of adoption of the moving into the cloud. I think.
Great. Thank you very much. Kristóf, would you like to continue maybe?
Yeah, sure. Yeah, from my point of view, especially for big customers, sometimes their own processes are the main blockers to move into the cloud. So they have some old or outdated internal processes which are not really fitting to public cloud solutions. And from my point of view, these internal processes need to be updated so that they can better fit to cloud integration. And I totally agree with Nabil that I also see that sometimes the customers want to compare the on-prem security solutions with the cloud security solutions, but they are not really comparable. And sometimes there are a lack of knowledge from customer point of view what kind of security services they can use on public cloud. And in that case, we can of course support our customers, but I see that sometimes that internal processes, but they have with security assessment, with data assessment, and so on. All this movement to the cloud is slowed down, or sometimes already even blocked, actually.
Also, sorry to just add one more thing. Also, it probably means a great amount of risk. Don't want to push to. So it is not
exactly. Yeah, you are right, Tamás, and that's also true that customers see a lot of risk actually to move to the cloud, and they have their own on-premise solution already, and moving to the cloud is a requirement for a lot of projects or departments from big customers, but the company's regulations and processes are not really fitting to that migration or movement to the cloud.
Okay, are there any comments from the others?
Yeah, from my side, I completely agree with this cultural problem, mostly with big enterprises. I think the largest enterprises and the longest time they spend on premise is the harder for them to change their mindset. and migrate to the cloud. Also, I see some kind of cost phobia. They are really afraid and uncertain of the costs, and it's a different mindset from the finance people. Because in the past, they spent a lot of money on hardware and initial investments, but at least they knew how much money they would spend. And now in this new world, it's really different, and they need time to adopt and change really their financial processes and mindset.
Okay, thank you.
We already talked about big companies, but talking about smaller companies, for example, for startups, they are already in the cloud mostly. So because it was not their problem, because they are usually technology focused, and the motivation from the team, just based on the technologies that they get attracted by, that was enough motivation for them to move into the cloud, and they have that growing rate, which cannot be fulfilled otherwise. But it is a bit of a problem for big companies because they are more focusing on the sustained growth. And this is a bit harder to have that control over the costs and the growing. So the cloud may not provide the best tool for them to support their risky move into the cloud in that way. What do you think about that?
I think you touched on a very important point for startups, how does it contrast with the adoption of the cloud. I think one of the drivers for startups is the pricing model. So they have no upfront investment. So I want to use services. If I am using the service, I pay for it. If I'm not using, then I'm paying zero basically. So the attraction of the pricing model in the cloud, that's what the startups they like, because from budgeting and stuff, they don't want to invest upfront, and they don't know where the results are. So yeah, very, very important point as well for and that's why you can see, like I said, the contrast. Cloud adoption for startups is very, very fast.
Levi, we cannot hear you. It might happen that you are on mute.
Yeah, sorry, I would like to add something. So I think that's important. So maybe at the beginning for startups is something attractive, no? But when the company is reaching some maturity, maybe that can become somehow not a problem, but it could be something that they have in mind quite often, no? Because sometimes, or most of the case, they don't have really the power to control the exact amount of money that they want to spend, no? And sometimes we have the problem, or they has okay, how can I control exactly the amount of money I can spend in Google Cloud, or how can I limit exactly the amount of money I want to spend, or how can I protect my billing account to don't really explode 1 month, no? So that's also something that it's happening, and at the beginning it could be like a benefit, no? But in some point it could be not dangerous, but something that is like keeping the people a bit like thinking about that, no? And also something that you mentioned is like the skill, no? I think it's hard to find people with a skill in, we are talking about Google Cloud, but I think in the different cloud providers, no? And it's also, I think some managers should also change their mind to have people skilled for all the different set of clouds or services that we have, no? So because it's hard to find a person that is like a unicorn, not to have knowledge in all the different platforms, no? And that's hard. So I think a change in that direction is good also. Yeah.
Okay, thank you very much. A lot of interesting thoughts. Any further comments, or shall we go to the next question? Okay, let's move to the next question then. We have already touched, and you also talked a lot about, the differences between bigger companies, smaller companies, maybe different needs as well. I would be curious, what do you think, how companies can balance security, governance, stability with innovation using cloud? Zoltán, if you may start.
Well, I think it's a very important question, probably for all companies, but for the bigger ones, it's even more important. And well, my thoughts around these are that for creating a new product, new architecture in the cloud, I think it's worth to use stable components, which were already probed, and there are references And even if it's a very volatile environment, and new services and products are appearing, really there are hundreds of components at each cloud provider. I think it's worth to pick the ones which are used for a longer time, where you have references which are built on standards, open standards. And maybe when you have set up your solution, then keep an eye on the innovations and the changes, and review and update your architecture regularly. And I think this is one way to balance these two things.
To support it, I think it also needs some processes being defined. And also there are some roles in the company which needs to be introduced if there were no need before. For example, compliance officer or security or governance point of view. Such companies usually need to maintain a good balance, and only way to do that is like having some controls in the system, ensuring that the innovation is still possible, but within barriers or doing the proper way. And that is really a challenging topic, I think, how such a company can do it, because it is really depends on their actual case, how they work, and what is their actual market.
Thank you. Any further comments from the others to this question?
I guess I would like to add it about the innovation. Right now, it's really hard to bring something that is not being discovered by the people or implemented around. There is a lot of sites where you can find some different solution, but very often those innovations are so simple that you need simply just to pick up and implement this. That I mean. Solutions are so obvious that you are not really seeing them, and you need to help to see and implement and move on with them. So sometimes you just need to step back, take a look on the process, what you can improve, and you will see the answer. It's really simple.
Thank you very much.
If I can just add an example for that, what just came into my mind, for example, automation. Usually such a company has lots of manual tasks, and automation helps the people working there, not by replacing their actual job, but just assisting so that they can spend more time on discovering the new way to do their business. And that way it will be beneficial for the whole company.
Okay. Any further comments to this one? If no, then go to the next one, which is about the different environments. What does it mean to you to manage a hybrid environment, a hybrid cloud environment? And what are the biggest challenges? Levi, if you could start.
Sure. So, yeah, let me first maybe mention what is a hybrid cloud, no, and what is a multi-cloud, no, because I think sometimes people doesn't have this clear now. I think we can somehow like mention like multi-cloud, like an environment where you have at least 2 public clouds, and you can have also some private cloud, but it's not mandatory, no. This is multi-cloud, and then hybrid is basically the same, but on top you can have your own on-premise, no, so resources. So this is hybrid. So, and it's clear that you have some benefits now when you have some multi-cloud or hybrid cloud now, that you can run the workloads depending of your needs in different cloud providers, or even you can run your more critical workload, for example, on your on-premise, no? And yeah, it brings more flexibility, you know what I said, you can run it in different environment, no? But also for industry where you have a highly regulated industry, no? For example, fintech and so on, where you need to ensure, for example, that your workloads are running in an environment that you have full control and so on, no? Maybe that's something important, not to have this option, not for hybrid cloud or multi-cloud. And I think Google, I mean, I know that you hear the news now, it's working on that with the cloud sovereign that is bringing next year. So I think it's going more in that direction. And I think key points that you need to have in mind when you are working with hybrid cloud or multi-cloud is to have infrastructure as code. I think we already talked about this in the different talks, no? But I think having something like a Terraform, for example, to have a single place where you can manage all your infrastructure is a must, no? So I can imagine managing hybrid cloud or multi-cloud without infrastructure as code. It's impossible to go provider by provider managing the different infrastructure, no? The biggest challenge, I think we mentioned that before, but it's skill people. So if you have a hybrid cloud or multi-cloud, it's hard to have people certify or skill in the different providers, no? And again, it's hard to have one person that has all the skill for all the different environment, no? So finding people for that, I think is hard. And I think it's where maybe the company needs to really invest in the team and building and finding the correct professional. And I will say that maybe not try to find one person with the full knowledge, maybe try to focus or in the different providers and find the correct people for every provider. That would be my recommendation, for example. Yeah.
Okay, thank you. Any reactions or any thoughts, or maybe you would just like to share your view on that?
I would like to add it on top of this, that Terraform and managing multi-clouds, yes, this is great, but many clients of us goes with the Kubernetes. So they try to manage the Kubernetes across many clouds and deploy their workloads to the Kubernetes. So they are actually cloud independent. They are more dependent on the Kubernetes and managing their workload. And Ant is one of those things that helps to manage the workflows as on-prem, as on cloud, and other cloud providers.
Maybe adding one more additional comment to it, that for me, actually, as Levi mentioned, some customers want to have their on-premise environment and next to that also the cloud environment. And actually finding the right connection between the two environments is something, but using the services which are running on the on-premise environment so that they can be used, consumed on the cloud environment, so that this is fitting for all the company's compliance and security regulations is sometimes a difficulty from my point of view. I mean, the identity synchronization, DNS, EPAM, and any other solutions which are running on-premise environment, but the customer want to use it on the cloud environment as well.
Thank you very much. Nabil, skills were mentioned a few times, and actually you work for a company, providing these kind of trainings. How do you see this problem, that it's very hard to find, colleagues who can be really expert, in different cloud environments? How can you manage that complexity, or how employees can manage this kind of complexity these days?
Yeah, I mean, it's challenging really these days. We've seen cases, like I said, there is resistance to change. So people don't want to take up new challenges, and the company is going to that direction. So it's not a matter of yes or no. It's a matter of when I'm going to need to. And so that there is this question to be which cloud provider I need to go with, because it's very difficult to be expert in every cloud. There's a huge amount of information to assimilate in there. So you need to be clever to where do I invest my time to upskill and to improve my profile. But the skill gap in the market is still huge. We see the adoption rate is going higher year on year, especially with COVID. We've seen from training perspective, we've seen an uptake, huge uptake in training, which means that companies are going to that direction faster. And the other thing is when it comes to the skills as well, is the mindset. The previous point that we talked about, for example, having hybrid challenges with security and networking is a different one. And the skill, when you talk about software-defined network and somebody working on devices and Cisco routers and stuff, and all of a sudden he's on the console to do configuration for firewalls, it's difficult as well. So it's a challenge when it comes to the mindset as well. But yeah, we've seen like a lot of kind of competition in the markets, even within the same teams. People try to compete, to take new jobs, take new skills. So I think the market as a whole is going into the right direction.
Thank you very much. Any further comments from anyone for this question from the round? Okay, then yeah, let's talk a bit about innovation and the customers. What do you think, or what do you see at the moment? How ambitious are your customers delivering innovation through their IT? And what opportunities do you see there, especially when cloud comes in? Vitaliy, if you may start.
Yeah, what I would like to bring here, that for the last 2 years, many of different companies moving to the digitalization, properly pronounce this word. So everyone tries to be as much as possible digitalize it. That means that many companies, different businesses try to invest in some innovation that actually helps them to bring the business to their clients. Different products, different companies, someone trying to play CapEx vs APEX, they move their workloads to the cloud because it's more cheaper. They can easily to expand their business, auto-scaling, grow it's present in some different region because there is a presence of the cloud in that region. Recent 2 years shows that many companies moving to the cloud and many moving to the Google, because the Google provides different kind of services like BigQuery, big data, ML, AI. Those things are not so popular in, let's call it, other cloud providers. Maybe Google was the first who introduced this, and that's why people are more interested in them. And yeah, recently I've been seeing the attention to ML and big data projects and helping of those toolings to bring some value into the business.
Thank you very much.
Anyone
like to continue?
Yeah, I would like to add something. So yeah, it's interesting what you mentioned. I think Google has a good potential in big data. No, I mean, we all know how Google is making money with marketing and so on. So they are like the most useful, for example, analytics tool. No, for example, like Google Analytics and so on. And it's super nice to know how they connect the analytics work with Google Cloud, no, for example, and how easy it is for the companies once you have one product to jump to the other and start to analyze the data and so on. So I think there Google Cloud is like one of the best in the market right now. And in my experience, for example, a lot of customers are like trying to go a bit beyond that and try to, okay, we have the data, we are analyzing the data, but what else? No, we want to activate the data. We want to get more insight. We want to, predict. For example, if you are talking about marketing customers, what is the behavior of the customer? What is going to buy? What could be interesting for the customer? No, and I think that for that, Google has a really nice setup with all the AI platform, and also in other customers, not just focusing big data, for example, they want to automate a lot of processes, no? And for that, for example, Vision API and stuff like that, where Google is also super powerful. I think the market right now is going more in that direction, and they want to get really stuff automated and try to bring the powerful of the artificial intelligence really to the table.
Yeah, I agree, and I would like to add that beyond that, GCP and Google can provide a really strong technical background for data processing and AI machine learning. They really have experience in data monetization, so they know how to make money out of data, and they can give good advices and suggestions and bring relevant business cases to different companies. I have seen that. And I think it's an added value, an important thing.
Anyone else? Okay, then the next one is the next one. I think, what challenges you are experiencing from using cloud platforms in the wrong way? When customer, for example, is still using, cloud type workloads as local environment and, these typical things. Tamás, can you please start?
Oh, very great question. Actually, there are so many things that a customer can do in a dangerous way. But just one example for that is that if they underestimate the risks and effects, if they are making wrong decisions when working in cloud. For example, you can think about security breaches. I think we already mentioned that, sensitive data leaks, and these can destroy whole brands and companies. But also there are some less harmful things they can do. But I think usually when they do that, they learn from that and they can recover from those mistakes. This was the very, very extreme cause for such a wrong and challenging situation I could just think of.
I have something to add. For example, like security, you mentioned that, Tamás, I think it's interesting. And we already mentioned that, so it's quite easy, I think, right now for startups and so on, start with cloud, no? And therefore, it's also easy to start with the cloud without the proper knowledge. And I think that with the time can bring some, let's say, I don't know if mistakes, but problem, no? Regarding, for example, security, no? You can, I don't know, work with some customer where you can see, for example, that they are working with service account where they have, I don't know, owner rights for some, so security stuff that in some moment it was okay for them because solve a problem, but then later it could become a problem, no? And some problem I see also is like they don't know sometimes the full potential of the cloud, and they try to reinvent sometimes like the well, no? For example, if they are working with artificial intelligence, sometimes they try to build something that the platform already provide, no? And probably is doing that better than like what they can do, no? And I think it's a matter of using what the platform already offered to you and try to use it in your benefit, no? And build on top of this and not try to reinvent something that is already there and would take less time for you to just reuse it, no? And it's better probably. So that's two things I think it's important.
These are great examples.
Yeah. Yeah, sorry, I want to add, because this is from real experiences, is when you use the cloud, very easy to create resources. So people were on premises. When you want a VM, you go through a whole process. You go to the service desk, you ask, it's a couple of days before you get that. In the cloud, click on the button and you create a cluster with the CPU, memory, and then and you leave it running. It's not doing nothing. So billing is a big challenge. The control of costs is some companies, they just run out at the end of the month with astronomical kind of billing kind of invoices. And one of the challenges is to control the cost. How the mechanisms, the governance you need to put in the cloud environment to control that. That's one of the big kind of challenges that we find now in cloud environment, not just in Google Cloud, but any cloud environments.
Well, I would like to also add it when the people bringing the wrong experience. So like they were running AWS and they moving to the Google and they try to manage the Google the same way as they are managing the AWS. They are failing, or they're trying to manage the cloud as they manage on-prem and they are failing. And that's really important. I guess Tamás will talk about that later, about the foundation.
how you make the proper foundation on the cloud. It doesn't matter it's Google, AWS, or Azure. You have to make a proper foundation. And based on this proper foundation, you can manage your workloads in the clouds. Don't bring your own, don't try to bring your bad experience into the cloud. It's better to learn cloud from the scratch and do things from the scratch.
Yeah, I do absolutely agree with you because it's completely different mindset. You know, when you're on the cloud, you've got global scale. People don't think, for example, about egress cost from networking perspective. So they brought resources in different regions, and even the networking costs will go up, and they don't realize that. So the mindset coming from on-prem to the cloud, which takes me to what you said, need to learn the right skills in the cloud from scratch to change that mindset in order to have an efficient solutions in the cloud.
Totally agree with you, Nabil and Vitaliy, that actually I think the mindset has to be changed sometimes on customer side, because if they are moving something to the cloud, doesn't really mean that they have to move the compute resources from on-prem to the cloud and creating competencies or something like that. They can more benefit from cloud, Google Cloud or AWS or Azure, if they are using a serverless solution with scalability, with availability, and all the benefits that the cloud can provide for customers. And I think, of course, that means additional effort on developer side, on the application development side, but I think it has to be considered that if the customer want to move to cloud, the serverless solutions are really important, that they can use it for their applications.
So wanted to mention that in typical situations, a lift and shift approach can fulfill the requirements, and the can handle the situation. But sometimes whole re-architecture is necessary for rethink the whole platform that the customer already operates, probably on-prem, and wishes to move into the cloud. And there are the documentations, there are the services to support them into the direction. And this is a whole big topic when the joint effort is necessary, not only from our side who support the customers into moving into the cloud, but also management of the customer, and also from actual teams at the customer side. So this is a bit hard to organize and get everyone interested into these activities.
Thank you very much. Any further comments? No. Then, yeah, it looks like that having the right mindset, that having the right skills are key to be successful with your cloud adoption journey. So thank you very much, colleague, for being here today. Our time is up. And regarding our audience, I hope you enjoyed the discussion as much as we did here. And see you next time. Goodbye.
Thank you.
Goodbye.